The formula for the mean is the sum of all the scores divided by the number of scores. We're going to expand this concept to the mean of any discrete random variable. The mean of table 5.8 is the sum of all the scores divided by the number of scores. But we want to express the mean age of students in terms of the probability distribution. Let's complete the table. We have 3 20s, therefore the probability of 20 is 3 over 8 or 0.375. We have 221. Probability of 21 is 2 over 8 or 0.250. And we have 127. 1 over 8, the probability of 27 is 0.125. The sum of all the probability is 1, or 8 over 8. Now let's go back to the age of those 8 students. Traditionally, we will calculate the mean by adding all the scores and divide them by the number of scores. We'll take a closer look at what this means. It means that you have to add those 219 to those 320s, then to those 221s, 21 plus 21, 227, and we have 8 of them. 1 2 3 4 5 6 7 8 of them, and divide the whole thing by the number of scores, which is 8. Now we're gonna break up the fraction. It means that you have 19 plus 19 divided by 8 plus 20 plus 20 plus 20, 3 20s divided by 8 plus 21 plus 21 divided by 8 plus 27 divided by 8. Now we have 219, so it's gonna be 19 times 2 over 8. We have 320, so it's gonna be 20 times 3 over 8. We have 2 21s, so it's going to be 21 multiplied by 2 over 8. 27 multiplied by 1 over 8. So it's the number multiplied by its probability, the number multiplied by its probability, and we add them. To obtain the mean of a discrete random variable, we multiply each possible value by its probability, and then we add those products. Multiply each possible value by its probability, and then we add them. So it's the sum of x times p of x equal to x. And that number is 20.875. Remember the formula? The mean is the sum of x times the probability of capital X is equal to x. This is your book's example, and it gives you 3 columns, one for x, one for p of x, and the other one for x times p of x. And the mean is just the sum of the third column. The mean is the sum of x times b of capital X equal to x. Therefore, the mean is 4.118. The standard deviation of a discrete random variable is similar to the standard deviation of a sample data. It's the square root of the sum of each particular deviation squared multiplied by its probability. Now, the computing formula is even easier. It's the sum of the square of each value multiplied by its probability minus the mean squared. It means the same thing as before. It indicates how far on the average an observed value of x is from the mean. The smaller, the closer to the mean. The example of your book is given using the computing formula, which is easier to calculate, and all three columns were already calculated. So remember that for the mean, we found 4.118. For the standard deviation using the computing formula, S is equal to square root of 19.438 minus 4.118 squared, which is 1.6.